Okay, a 4 kilogram object is moving 15 meters per second. If it stops due to friction in 3.5 meters, what is the magnitude of the force of friction? Don't be afraid of the word magnitude. We're just size. How big is it? How much? What is friction? All right, so if friction, we're looking for, friction is a force. So let's go ahead and set up our conservation of energy equation. What kind of energy does it have when it's moving? Kinetic energy. So we've got kinetic energy. It's coming to a stop. So what force is acting? Or what? We got friction. And so since there's a force, we have work. So we've got work, plus or minus work. Now, what's it going to end up being at the end of this equation? What's the end scenario? The box comes to rest.
Zero.
It's zero. Because the height is zero, the velocity is zero, it's zero. So we have kinetic energy plus or minus work is zero. So let's go ahead and start setting this one up. Our kinetic energy formula is 1/2 mv squared. Our work formula is force times distance cosine theta equals 0. We can, well, we're going to leave cosine theta in there because it's kind of important in this one, okay? 1/2 mv squared. We know the mass of our box is 4 kilograms. It's traveling initially at a velocity of 15 meters per second, and we've got to square that value. In our work formula, we're solving it for F. We want to know what's the force happening here. So force, the distance they gave us in the equation is 3.5 meters. So we've got 3.5 meters. And now cosine, we got to look at the direction of the force versus the distance that it's traveling. So we know that it's traveling to the right, but it's being slowed down. And what force is going to slow it down? Friction. And what direction is friction? It's the other way. So we've got going here, our force of friction is in the opposite direction. So what degree is that? That's 180. So cosine of 180, if you look at that, type it in your calculator, cosine 180, what do you get? -1. So that's telling us that our work value is negative. So we got work is negative work, so negative FD cosine, negative here because of that cosine 180. Okay? Pardon? What's negative? Work is negative. And then that is equal to 0. So we're going to end up with 15 squared times 4 times 1/2. That's 450. And it's kilograms, meters squared, seconds squared. Now what I'm going to do over here is I'm going to take my negative work and I'm going to move it to the other side of the equal sign so that I'm working on both sides instead of just one. So 450 is equal to force and times 3.5 meters. Drop in the cosine 180 because that's 1. That's what gave us our -1. So now since I've got the 3.5 meters on the right with our force, we can divide both sides by 3.5 meters over 3.5 meters. So 450 divided by 3.5, you should get 128.6. As far as my label goes, we're going to cancel out the meters here, cancel out one of those. So if you remember, so it should be kilograms per meter second squared is a Newton. So my force is equal to 128.6 newtons. On that same problem, how much energy did it lose? Well, since it had 450 joules of kinetic energy as it was sliding along, it lost 450 joules of kinetic energy. So the work it lost is 450 joules. On part E, since this energy was lost in 2 seconds, how much power did friction dissipate or use up? So now we got to go to our power formula. Power is our work divided by our time. So I'm just going to kind of erase this over here so I get a little more board space. Power is work over time. Well, how much work did we have going on in this particular problem? It ended up, we had 450 minus 450 equals 0. So my work was 450 joules over my time, and the time it takes to slow down is 2 seconds. So 450 joules divided by 2 seconds, that means my power is 225, and our label for power is the watt. So 225 watts.